Okay, sorry about our video earlier. It got cut short because of network, but here is a brief about the number systems. Okay, so we have the number systems. Under the number systems, we have the real numbers and the imaginary numbers. Now, under the imaginary numbers, we have what we call the complex numbers. Okay, the complex numbers, they are the ones that have I, 3I, 4I. That I is to show that they're imaginary numbers. Excuse me, the I is equal to the root of -1. Okay? Now, then our main interest is in the real numbers. Okay? Under the real numbers, we have the rational numbers and the irrational numbers. Okay? The irrational numbers cannot be expressed in the form of A out of B, where B is not equal to 0. So in other words, it cannot be expressed as a fraction. Okay, A and B are meant to be integers. So an irrational number cannot be expressed in the form of a fraction, that is A out of B, where A is not equal to 0. The best example of an irrational number I can give you is pi, which is 22 out of 7. Then we go to the rational numbers. These ones can be expressed as fractions. Okay, they can be expressed as fractions, that is in the form of A out of B, where B, which is in the denominator's position, is not equal to 0. A and B are integers. For example, a half, 3, 5, 7 out of 4. All those are rational numbers. Okay. Now, under the rational numbers, we have the integers. Okay. The integers are numbers which are not fractions. Okay. If a number is not a fraction, then it is an integer. For example, -1, -4, 5, 6, 7, 8, 0, 9. Okay. For as long as a number is not a fraction, it is an integer. Then we still have whole numbers. These are counting numbers from 0. Okay, so it can be 0, 1, 2, 3, 4, 5, so on, 100. Okay, as long as it starts from 0. Then we have the natural numbers, which we also call the positive integers. So the positive integers are from 1 onwards, up to whichever number you want to stop at. Okay, so basically, this is the number system in short. Bye-bye. I'm teacher Basemera Stella Maris from Creative Learning Africa. Thank you. See you next time. Some questions earlier. The first question goes, how can you justify that pi is an irrational number? Pi cannot be expressed in the form of A out of B, where B is not equal to 0, and therefore it is an irrational number. Even when you write it in a decimal form, you will not get a definite answer. You will get a continuing answer, and those are called recurring fractions. So most recurring fractions are irrational numbers. So therefore pi is an irrational number because it cannot be expressed in the form of A out of B, where A and B are integers and B is not equal to 0. The second question says, real numbers can be separated as a set. Let me see. This one sounds. Real numbers can be separated as a set. Does complex numbers can complex numbers be separated as a set? If so, what is the first element? As I said earlier, we have the real numbers and the imaginary numbers. Okay. Now, you can write, well, as I gave the example of imaginary numbers, we have the I, 3I, -2I, so it is a set of their own. Then real numbers are the usual numbers. I have one, all the numbers on the number line are real numbers. So this is a set on its own, and this is also a set on its own. These are two different kinds of numbers. I hope I've answered you. Then the third question was, what can you say about the combination of rational and irrational numbers? When you combine rational and irrational numbers, you get real numbers. So next question is, what is the importance of surds in real life? Sorry, in real numbers. Surds help in calculations, okay? They help to simplify calculations. Now imagine I have 2 root 3 plus 2 root 3. If I'm to add them, I can as well just say it is 4 root 3. But imagine if that root 3 was expressed as a decimal, of which it may be a recurring number. So I express that root 3 as a decimal, then with the root 2, and then add it up. So I'll end up getting something so big, implying that my calculations are not going to be simplified, they're going to become complicated. So the basic importance of real number, of surds, is to simplify calculations. Even engineers, when they're making building calculations, for example, bridges, it is easy for them to use surds so that their calculations can be precise and accurate. Then the last one says, how are logarithms useful in engineering? Okay, so engineers, I'll give an example of chemical engineers. They use logarithms to measure the alkalinity or the acidity of a substance. That is the hydrogen potential, or what you would call the pH. Okay. Then logarithms are also used to measure the degree of earthquakes. They say that the magnitude, basically the magnitude of earthquakes. They are also used to measure the brightness of stars. Also used to measure the radioactivity of a substance. All these things use logarithmic scales. I hope I've answered your questions the way they were meant to be responded to. Thank you very much. Teacher Basemera, Stella Maris. See you next time. Bye-bye.